Hello, everyone. My name is Deepak Suri. I'm the General Manager for Application Recovery Controller at AWS. You are in ARC309. Today's session is a little bit of an upgrade over what the session title that you saw. You'll notice the word automatically here, so it's automatically recovered from an AZ impairment. This is because we launched a new feature today that I'll talk more about later on. What I do at AWS is help drive customer impacting events to be fewer and shorter. And as part of that, my team builds both tools and processes and operates them both for internal AWS services and also provides capabilities externally to customers. So a lot of what we'll talk about today is AZs and, of course, availability zones. It would be awesome to get a show of hands if you deploy to multiple AZs today. I can kind of see. OK, awesome. And how confident are you with your AZ recovery process? If you could raise your hands. If you're very confident, raise your hands too. OK, awesome. I see at least one hand there. This is great. So in this session, you will hear a lot about how AWS uses AZs effectively, the origin story around AZs, and hopefully you'll take away some of that and apply that into your multi-AZ environments. You'll also learn a bit about autoshift, which I'll talk a lot more later on, a capability that we launched today around helping with AZ recovery. With that, I'm going to hand the mic to Gavin to talk through the first part of this presentation.
Thanks, Deepak. To give you a little bit of my background, my name is Gavin McCullough. I've been in AWS for about 12 years, and I started off in the Dublin office in Ireland, working on our team that owned Amazon's load balancing, and shortly after that also in Amazon's DNS. And we were very integrated, or we were a very sort of central infrastructure team who spent a lot of our time worrying about making sure all of the service teams that were working behind the load balancers were able to recover whenever there was any kind of issue within an AZ. And so what I'm going to be, I've also more recently worked with Route 53, and I'm one of the call leader team for incidents within Amazon. And so I'm going to hopefully take you through how Amazon uses availability zones. So I guess the first question, a lot of hands went up when you said you all deployed to availability zones. But very quickly, I will just give you some kind of background on why. I think Amazon launched availability zones publicly in about 2007, something like that. But I think we'd been using multiple data centers for a while, so it was kind of us putting a name on the concept more than anything. But you can imagine Amazon retail back in 2006-07. It's a company that's growing fast. And one of the things that we're starting to notice is that reliability for customers is really important. People are starting to depend on the website, and it's really business impacting if there's any kind of issue. And inevitably, we're going to have some failures. We kind of have to accept that. But the real important metric for us is what happens when, or how quickly do we recover when we have any kind of failure. So just to give you a little bit of context of just like how critical it was becoming at this point, in 2007, these are the sorts of things that Amazon was doing. We had this big online retailer website. We had launched Kindle. We had Prime Shipping had just launched. There was this fledgling thing called AWS that not that many people had heard of. Some of the people who read Slashdot a lot had heard of S3 and SQS, but it was still quite small. We had what was called Amazon Video On Demand, is now Prime Video. And the company revenue was growing pretty healthily. And when I joined in 2011, as I said, I joined onto the load balancer team. And the advice that I was given when going on call, I happened to be going on call around this time of year for the first time. And it was what we term Q4 peak. So this is like Black Friday, Cyber Monday, these kinds of days when, well, there's a lot of traffic going through, there's a lot of orders, and everybody is particularly watching carefully how things are going. And he basically said, in Q4, minutes means millions. And what he meant by that was, if we have some impacting event ongoing, we need to be fast, decisive, and we need to recover really fast. Because the difference of a few minutes will literally mean millions of dollars of sales. So this was a mentor of mine in Dublin, and I somehow never forgot those few words. Now, it's worth putting this in context that, I don't know how many people in this room would say that minutes means millions for them? Certainly a decent smattering. It isn't true for everybody, and it probably isn't true for every service you own either, even if you do have some. And redundancy, in order to really, really get the best recovery times, you need to have redundancy in place, which I'll talk about a bit more. That isn't free, so you do have to think about the trade-off for your applications and your business. So I don't mean to say that everything we talk about here should be done in absolutely every application. You kind of have to pick the right battles to win on this. So again, it's all about time to recovery. And the philosophy that Amazon has advocated for a long time, not one we invented, it's in the industry literature, is recovery-oriented computing. And like, the too long didn't read is, rather than trying to fix things when they break, make sure you have redundant copies of everything. And when one of them breaks, just shift away from it, recover the customer experience quickly, then go and repair it. And so that might mean an impaired host. Typically, you'd use a load balancer health check, take the host out. It might mean whole racks failing. It might even mean an impaired data center in some situations. One of the really cool things about working within AWS is I get to talk to the people who manage our data centers and design them. And it is flabbergasting the kind of energy and investment that goes into building these incredibly resilient data centers with redundant power, networking. If there's a power issue, UPS kick in quickly. If we don't recover in the time the UPS can, the backup generators start up and keep us going for hours. There's redundant cooling. Like, there is an immense amount of redundancy goes into a data center. But in practice, we still had to admit to ourselves that we're never going to build a perfect data center. There's always going to be something occasionally. And so these aren't common events, but they do exist. And so as Amazon, we had to look at it and go, okay, if we want to provide the very best reliability for customers, we can't depend on one data center. And so the design that we hit upon, which sounds like all of you are reasonably familiar with, is availability zones. Now, you might say, coming into this, well, we'll put one data center on the East Coast, one data center on the West Coast. Keep in mind, Amazon is a lot smaller than you could have done that. But the problem with that is that really what you want to be able to do this effectively is have multiple data centers operating active-active so that customers don't care whether they're talking to AZ1, 2, or 3 at any time. And that's great when a customer clicks add that item to my shopping cart. If they happen to flip between AZ1 and AZ2 at that time, you want that to be in the shopping cart in the other AZ as well. And so what we need is synchronous data replication, meaning that when a write is made in AZ1, it is also made in AZ2 and 3 before we move on and confirm the write. So there's never data inconsistency. So the purpose of AZs is to be close enough together that we can do synchronous writes. The typical round trip time between AZs in the order of 1 millisecond. And that allows us to quickly make writes between them. If you were going cross-country, you'd be talking about a 50 millisecond latency. And it's very, very difficult to do synchronous writes with that and keep performance good. So these are close enough together that we can do synchronous writes, but we also don't want them too close together. So they're typically a few miles apart in order to make sure that if there's a flood or something, we don't see multiple AZs failing at the same time. And over the years, things have grown a little, and typically AZs, you can still think of them as one data center if you want, but they are actually more often in the big regions, several data centers. They tend to be closer together when they're parts of the same AZ, because that's what we want them quick. But you can still think of it as just a big AZ from a practical perspective. So a couple of other observations we've made over time, and this again is nothing secret. It's out in the industry fairly common to see the distinction between hard failures and gray failures. So if you have a host and the host loses power, or the host stops answering on, or stops listening on whatever port the application typically listens on, that's a very unambiguous failure. a health check probe will very easily tell you this host is not healthy anymore. And so it's fairly easy to use load balancer health checks, simple things like that, to detect those kinds of failures. Gray failures are a little bit more difficult to deal with. And in distributed systems, gray failures become a lot more common. And the problem here is that depending on who's looking, the question of whether something is healthy or not may become a little bit ambiguous. So for example, the host is now answering significantly slower. Is it still healthy? Is it not? It kind of depends on the caller, whether you're happy with that level of latency, or maybe it's intermittently failing. And a simple health checker will typically check multiple times before calling something unhealthy. So it can stay in service, continue passing health checks, even though it's failing like 10% of requests. And the way we've looked at to deal with this is to say, we're going to make sure that we're going to be, from an infrastructure perspective, redundant to handle a failure of a data center or an AZ anyway. So let's just make sure that all of these gray failures get contained within one AZ, and then we can shift away from that data center and then go examine what exactly is going on in there. And so the kind of irony of this is that you go after building these super resilient systems across multiple data centers, and they're highly redundant. They're distributed systems. The slight irony is that they tend to create these gray failures. You very rarely see hard failures in a well-designed multi-AZ system. What you tend to see is gray failures. So very quickly, to make that a little bit more concrete, what would a gray failure actually look like in an AZ? What are the kinds of things we see? And so I mentioned before, these aren't that common, but we've been looking at this or I've been looking at it for sort of 10 or 12 years, and at this point at 32 regions. So this is based on quite a lot of experience. Most regions go years between significant AZ gray failures. And a lot of the time, most customers don't notice. So if you imagine in that multi-data center environment, we lose one room full of instances, that's probably 5 or 10% of the overall AZ, because there are multiple data centers and we're only talking about part of one. So a lot of customers won't even notice it. But nevertheless, if you're looking for the very best resilience, you may want to be able to handle that anyway. So like I say, it's extremely rare to see a whole AZ down. I think we could track down arguably one in the last 10 years in one particularly small region, but that is a very unusual situation. So if that's your mental model, you kind of have to adjust it a bit more toward gray failures and not that kind of hard failure. So yeah, the real life examples, a relatively small percentage, like 1, 5, 10% of instances in an AZ lose power. That's not uncommon. If you have a decent sized fleet in that AZ, you may lose a few of your instances. If you happen to have a very small fleet and you get very unlucky, you might lose some more. Intermittent packet loss occasionally within an AZ will happen. Congestion will cause that, or a failing network device. It takes us a few minutes to correct that. Same kind of thing with intermittent connection failures sometimes. These are all gray failures. The host is probably still mostly working, but it's having problems connecting to a dependency, or potentially looking with DNS lookup failures in one AZ. But again, these are all tied within one AZ. So if we are redundant, we should be able to just shift away from that AZ. Occasionally, you will see intermittent EC2 launch failures in an AZ as well. So when an application is designed to be multi-AZ, the typical outcome of these is the application is continuing to work, but it's seeing elevated latency maybe in some requests intermittently, or errors in a few requests. And that's the kind of problem that we're trying to handle here. If the issue is contained in one AZ, we can just shift away, and then we can work out how to fix the problem. So how do we design as AWS for AZ resilience? And I won't go into this. This is a long topic with a lot of detail, but just the kind of high-level topics to be thinking about. The first thing is you should step back. This is probably obvious. Step back and think holistically through the whole application. There's typically multiple layers and multiple components involved, and you've really got to think about all of the pieces. You sometimes see customers who will lift and shift an application from on-premises. Totally reasonable thing to do. But they relied on a single relational database on-premises on a single host that is failed over manually. Not an uncommon setup, but the challenge is that that's going to be one of the things that you're going to want to fail over quickly. You will want that to be automatic failover if at all possible. So thinking through all of the components of the application and making sure there isn't anything that's going to linger in the impaired AZ. And I guess that's related to making sure you have no single AZ dependencies. If you happen to use single AZ or DS databases, which are very useful for test environments, for keeping things cheap, but they're not really the kind of thing you want for a highly resilient application. So watch out for anything that just runs in one AZ. When you spread across the AZ, you really want to make sure you have equal capacity per AZ. It's occasionally easy to end up with a concentration of your capacity in one AZ versus the others. And if you do that, if that is the AZ that's impaired, you're going to have a difficult time because there's only a smaller amount of capacity in the remaining AZs. A thing that isn't always obvious but really want to call out is when AWS builds services within AZs, we operate pre-scaled with enough capacity that if one AZ just disappears, the other AZs will be able to keep going. There might be slight degraded latency, something like that. We are losing a bunch of capacity, but we make sure that we have enough capacity online without scaling up at all to handle the load. And that's a really important tenet. And pretty well all of the AWS services are built with that in mind. So one of the things that you may not even notice or think about is take DynamoDB or S3, for example. Those services are constantly running at about 66% of their capacity in most cases, because they are built to be able to lose an AZ anytime and just keep going. The other thing, once you're building the independent AZs and spreading the capacity out and making sure you're pre-scaled, is to really try to make sure, given that you're going to be able to shift away from an AZ, that you minimize coordination between the zones. And the reason for that is the coordination is what tends to create multi-zone failures. So for example, you may want to deploy only one AZ at a time, because that allows you to say, well, I've had a deployment in one AZ, it's causing a problem, but I know I can shift away from that AZ before I even can, much quicker than I can roll back. Another thing to think about is if you use caching, you might want to use individual caches per AZ, because occasionally caches can cause problems too, and you don't want it to cause a problem across the region. I think just to particularly focus in on the one part of most applications that you really do need to be consistent across the region is typically a database. I mean, it depends on the application, but there's some kind of consistent data store that you really need to be region-wide. The example of the shopping cart, you need the shopping cart to be consistent no matter which AZ we're in. And this is an area to put in real careful focus. Your database really needs to be able to recover pretty well immediately with no data loss if there is an AZ problem. Typically, all of the designs we have use either a quorum or leader election when doing this. Now, as AWS services, if I'm building a new AWS service, I don't build a new load balancer. I don't build a new database service unless I am a database service. We will tend to use Dynamo, Aurora, RDS, those kind of services. They design in recovery from AZ impairments so that we don't have to. I can completely understand, of course, that if you're moving from on-premises, you may lift and shift initially, but probably one of your top priorities is to at least make sure that you know how you're going to recover, ideally by switching to one of these managed database services. So moving on, how would we detect an AZ gray failure? And the way we tend to do it is, for a given service, is to look at our customer experience. The left column is the one that pretty much everybody will always look at. But the three other columns are a bit more novel, where we want to be able to see what the customer experience is. That's the leftmost column. But the three other columns are showing you what is the customer experience for a customer in a specific AZ right now. And the reason to do this, I've got a canary running against each AZ here, is if there's a problem, we see the customer experience is impaired, so we have a problem. But by comparing the performance in each AZ, we can start to see where the problem is. And so essentially, we're doing outlier detection here. We have 3 replicas of our service, and we're looking to see is one of them an outlier. Won't always be, but in a case where it is, the logical thing to do to recover from this event is to take AZ3 out. So next question, now that we've detected something, how do we respond to the gray failure? So this service is pretty standard. Clients are talking to a regional load balancer shown as its 3 component load balancers. And we have compute instances behind, and we're seeing, near enough to 100% success in all AZs, but they're all the same. And so our aggregate success rate is pretty much just the average of those. But then something happens, and we notice a success rate drop in the 3rd AZ. So now our aggregate success rate has dropped. Now, it's still 96%, and you might say, well, that's not terrible, but if you're running an e-commerce website and 3% of all page loads are failing, that's not great. So this is the kind of gray failure issue that we really want to be able to clear up really quickly. A 3% failure rate on most AWS services will set the phones hopping pretty fast as well. So this is the kind of thing that we really need to fix fast. There are lots of applications for which this is kind of like, yeah, we'll just wait it out, that's fine. And that's totally reasonable. So the product that we launched last year, which was essentially giving customers the tools that we've been using for over a decade in AWS, was called zonal shift. And the idea is to steer traffic temporarily away from that zone. So we start a zonal shift. As it's in progress, you start to see the aggregate success rate is going up. And that's because traffic is shifting away. And what's happening is, as clients organically reconnect, they're reconnecting to zone 1 and 2. Now, zone 1 and 2 are now getting significantly more traffic than before, and that is an important thing to keep in mind. So we've probably increased traffic in 1 and 2 by about 50%, and we've drained traffic from zone 3. We haven't actually fixed the problem yet. Zone 3 is still showing its 88%, but the aggregate success rate, the customer success rate, is back to normal. So this is recovery-oriented computing. We fix the problem for the customer first by simply shifting away from the problem, and now we go look at what's going on in AZ3. Maybe there was a deployment of those instances. Maybe there's an infrastructure issue. Who knows? So there's an interesting topic here. You probably heard this expression of shared responsibility in a security talk more, but it applies here as well. I mean, it really is just the question of there's a boundary of where AWS can manage things, AWS makes decisions on your behalf, and then in some cases, the customer has to make the decision or possibly take some responsibility. And the same kind of pattern exists here, and I'm going to talk through some examples to make that clear. There's a slightly weird thing that I'm talking from the perspective of building an AWS service on top of other AWS services. So imagine I am building some new AWS service. I'm not going to build my own load balancer fleet. I'm not going to build my own database service. I'm going to use those AWS services. So I'm very much a customer of AWS while also building an AWS service. And if I want to be able to recover quickly from an AZ impairment, I really need 2 things. I need to be prepared in advance whenever the event comes to reduce my capacity by 1/3 if I'm running in 3 AZs. And I need to be able to rapidly detect that this is happening, take action to shift. So the shared responsibility question comes in for how we think about each of these 3 layers. So the load balancer layer is an ELB managed load balancer. Very few customers run their own custom load balancers. Some do in AWS, but not that many. So I'm picking ELB. And in that case, ELB scales me without me asking with enough capacity to lose 1 AZ. If you build a multi-zone load balancer, they will make sure there's enough capacity that if one zone has a problem, they'll just pick up the slack in the other zones. So I don't have to worry about that. ELB will also do the detection and recovery. If the load balancer service is having problems in that AZ, they'll shift it. And on the database end, I've chosen to use DynamoDB, which is a managed regional service. And again, DynamoDB makes sure there is enough capacity for any one AZ to go away. They will keep going. They have enough capacity. And they do the detection and recovery for you. That's on our side of the responsibility boundary. The compute layer in the middle is where things become a little bit more complicated. The thing is that, in this case, we want to make sure that we have enough EC2 instances to handle the loss of one AZ's worth, or about a third of them. But the customer decides ultimately how many EC2 instances to provision. So this is the bit where it's kind of my responsibility as the customer of EC2 to decide how much capacity I will have and to make sure I have enough to handle an AZ impairment. And then equally, because I make that decision, I really have to have a hand in making the decision whether we're going to shift away during a gray failure. Because if I decide to run really hot and lean, maybe that suits my costs, I need to be able to say, well, this is a gray failure, I don't want to fail away. And so we really need to ideally involve the customer in that. AWS finds it difficult to make a decision like that when we don't know the application, we don't know how redundant it is. So just pointing that out explicitly, the elastic load balancers, and in this case DynamoDB, are handling 2 layers, but the third layer in the middle is more a customer shared model. It is true that elastic load balancing, the reason I say shared there is that elastic load balancing will health check those instances, and that will work pretty well in the case of hard failures of instances. But if there are gray failures, if it's slow to talk to them or something like that, health checks don't always fail. So ELB certainly does help, but not solve the problem entirely always. So the shared responsibility model, it's useful to know which services that issue even exists for. There's a whole set of services that are regional, and these are some examples, where they don't even present AZs to you. They just run. So S3 is an example. You don't put your data in a zone with S3. You put your data into the regional service. They are running across AZs, but you don't have to worry about that. It is entirely on the AWS side. Same for DynamoDB, same for Lambda, API Gateway, SQS. Those guys, if there is some issue in an AZ, it's their responsibility to deal with it, and you don't have to worry about it. And that is a very valuable property. If you're using EC2, as I mentioned, there's some more responsibility on your side if you want to be able to recover really quickly from an AZ issue to provision enough capacity. If we're talking about RDS, you have the choice between a multi-AZ or a single AZ RDS database. And if you want to be able to recover, you're probably going to need to to choose a multi-AZ RDS database. So before I hand back to Deepak, I just want to go through a couple of other architectures that we use when building AWS services to kind of give you some idea of what we're doing. So this one is one that I really like because I don't have to own anything, at least not in AZ recovery terms. So we've chosen deliberately 3 regional services here. API Gateway is regional. They own all responsibility for AZ recovery. Lambda is a regional service. They own all responsibility for AZ recovery, and same for Dynamo. So there's no zonal shifting on my side. They look after all of that for me. I don't have to worry about pre-scaling for these issues. They look after all of that. It's one of the things that maybe I sometimes think the Lambda guys and API Gateway guys don't say enough. We're building in a ton of spare capacity to make sure that we can just make these issues go away. So the cool thing is, in our shared responsibility table, it's all green. API Gateway is handling it, Lambda's handling it, and Dynamo's handling it. So this is the web service we talked about before. And so we're going to set it up fairly simply with load balancers. We have balanced fleets behind. We're going to pre-scale our capacity. And we're going to use a managed AZ resilient database. And that leaves us with this table we saw before. And one of the things that we're trying to do here in a way, is to figure out how do we give as little responsibility, or how do we make sure that AWS can handle the undifferentiated heavy lifting as much as possible. And the same thing applies when we're building internal services. We would rather have one team able to look after that problem rather than asking 100 teams to do it. And so we have, like I say, there's several hundred AWS services in a modern AWS region. And they often consist of many microservices as well. So organizing every one of those teams to quickly react in one of these events is a hard job. So what we do instead is make an agreement between all our teams. We will all make sure that we are scaled for this event to happen. And then we give our incident response teams the responsibility to detect the thing and shift everybody. And that speeds up the response time amazingly. So when we talk to customers, it's not uncommon for a similar situation to arise in a big company where you may have 50, 100, 200 services running in a region, and you're in the same situation. So centralizing that detection and response is a really useful thing to do. And essentially what we're doing is changing the responsibility model around a little bit, that our incident response team handles that detection and recovery problem. It's still on those service teams as customers to do the scaling, though. So a thing that we see also quite often is microservice architectures. We build a lot of these. I know so do a lot of customers. And so it isn't really one web service like this. Over time, it grows into, well, we have one stateless front-end service, but there are many functions behind it, and we might have 1, 2, 3 microservices behind it. Actually, very often, it's 50 or 100 microservices behind in the really big cases. And the challenge here is we're creating more of these kind of coordination problems. We have 2 different ways to handle this internally, architecturally. The first we call a siloing model, where we silo calls within AZs between microservices, and I'll show a picture of that in a minute. And then we have a more decoupled model. So I'm just going to go through those concepts quickly. So the AZ siloed model, you can see the client makes a call to AZ1. That's fairly random. They chose whichever AZ DNS told them to. And then when those hosts make calls to the backend microservices, you notice they're all appearing in AZ1. If the client hits AZ2, all of the backend microservices calls will land in AZ2 as well. And with AZ3, all the backend microservices calls land in AZ3. And the joy of this is, if we want to recover from an AZ impairment, we take AZ3 out just on the front end, and all the backends will start to go quiet in AZ3, even though we made no change at all. So this is a really handy property, especially for one of these kind of microservice models. It just means you have fewer things to change when the real event happens. You do still have to think, though, about the capacity problem, because all of those AZ1 and AZ2 microservices are now seeing increased traffic. One of the kind of issues that we found over time is that this model scales up to a certain point, and then it becomes a little bit difficult. The reason that most customers and most teams that I've worked with want to build microservices is because they want to have many teams operating independently, and they don't want to be all up in each other's stuff trying to figure out coordination between them. And the difficulty with operating a siloed model is, let's say the front-end service decides to add capacity in AZ4. Now every other microservice has to follow suit and say, well, we're all going to deploy in AZ4 because the front end now needs capacity in all our services in AZ4. And that's not ideal, especially if you have 20, 30 teams involved in that decision. Equally, when you're deploying, and I've seen teams do this, they will have an AZ of the day to deploy to. So if the front-end service is deploying in AZ1, there's some risk that might go wrong and you want to be able to shift away. But if one of the back-end services is deploying the same day in AZ2, or at the same time in AZ2, then you have the possibility that you will break multiple zones at the same time. You really don't want that. So again, it leads to more sort of shared, coordinated responsibility between the teams, and so that's one of the downsides of this. And it's really a trade-off. So I wouldn't say don't use this, but just think about the bounds of it. There's a certain point at which it becomes too difficult, I think. But doing this actually became much easier very recently. A couple of weeks ago, NLB launched a feature which they call AZ Affinity. And what that's actually doing in practice is transparently, if you turn it on, doing this. So if you look at the bottom left load balancer here, when the front-end service looks up the regional name of that service, it will get back the AZ1 IP every time. And the benefit of that is that effectively this siloing just happens automatically. So very, very easy to turn on. And where previously you would have had to have actually engineered each zonal fleet to make calls explicitly to an AZ, you can just turn this on in NLB now. So the other alternative is, I guess, a decoupled or non-siloed model where each of these load balancers or each of these services just call each other as regional, doesn't matter which AZ. And that does allow a greater level of decoupling. The services just treat each other as regional units. And it means that each of them has to recover from the AZ independently, because there's nothing saying that the front-end service can't call AZ3 on the other on the other services. So this means that we need each of these microservices to shift away from AZ3. So again, I guess this is kind of a trade-off. You might start off with a small, tight-knit team, 2 or 3 microservices, and this siloed model might work really well. You might find over time, as you get larger and larger and you want more freedom between teams, that it may not always scale. But it does give you a very easy recovery path. And again, we are kind of looking at this shared responsibility model that, or at least for the decoupled model, within Amazon, what we tend to find is that if we have our incident response team ready to handle all the microservices as well as the front-end service, that's not such an issue. We're not asking all the teams to react. So before I hand over to Deepak, some quick kind of learnings from our experience. Thinking carefully about each application's design is really critical. Like, how is my load balancer layer going to recover from an AZ impairment? How is my database layer going to recover from an AZ impairment? How is my compute layer? If I have a cache, what will that do? And just thinking that through, ideally testing it maybe with fault injection service, and generally making sure that you get that right. And what that will tend to do is you will not go down in any AZ impairment. You might end up with a low-level gray failure, though. And so the second thing is being able to turn those gray failures without worrying about what they are or how to solve it, turn it into a hard failure. Say, look, I'm just going to pretend that AZ is down. I'm going to stop sending traffic to it until we can figure it out. As a general rule, when building on behalf of AWS services, we tend to prefer managed regional services. A lot of our services use that Lambda pattern because it is so much more straightforward to operate. We also make sure that wherever we're doing this, we are pre-scaled. Whenever we want to shift away from an AZ, we do not want to wait for our recovery to wait on auto-scaling to scale us up. We want to have enough capacity that we're happy to just move, know it will work, and then worry about and then start to worry about what's going on in the AZ we've moved away from. And ideally, when we have a lot of services involved, it really does help a lot to have a central team detect and shift where possible. The other thing is that you don't really want to go 18 months between the times you do this. You really want to have a regular test cycle. And so I'm going to hand over to Deepak now, who's going to talk it through autoshift. But one of the things is, as we're building tools internally, we're starting to expose them more externally. So the tools that Deepak's going to talk about are really informed by a lot of these learnings. So I'll hand over now.
Thank you, Gavin. So as Gavin said, a lot of the tools we are trying to also externalize so that we can help our customers recover from a failure in AZ as well. So the thing that I'll talk about more is zonal shift. It's a reliable way to shift client traffic away from an AZ. It's something that Gavin walked through earlier on for how we shift traffic. So this is that capability. It was launched last year. And the way it would apply, going back to a couple of the architecture types that Gavin discussed, in the siloed architecture, a zonal shift would apply at the front end. That way, you are blocking off traffic flowing through AZ1 in this case. In the non-siloed architecture, you actually have to apply that per microservice that is running. And you would do that for AZ1 for each of these microservices. So in each of these models, effectively, if there was a failure in AZ1 and there's a gray failure, you've turned that into a hard failure and removed that AZ from service for your application. So zonal shift itself is a simple API that you call. It is meant to shift traffic away without trying to reconfigure any resources. So basically, that means that you're not actually there's no changes to your resource templates. There's no drift in your resources. So when you detect an event, you apply zonal shift. And when the event is passed, you come back. There's really no change to your resources. As you can imagine, this type of an API is called when there is an event in progress. So the service behind zonal shift is already pre-scaled and is going to be available for the extra load that comes in when customers call the API. It's a regional API. When Gavin talked about the regional versus zonal model, this is on the AWS side of the shared responsibility model, where we maintain the availability of the API even during an event. Practically, how this works is you apply a zonal shift by a resource. So in this case, what's called out is a zonal shift is being applied to an elastic load balancer node in AZ2. And what's important to notice here is also the expiration time. So it is a temporary action. So it's a temporary shift of traffic away from an AZ, in this case, AZ3. And the expectation is an event is going to be passed before the expiration. So in which case, you cancel the zonal shift at that time. Or if an event is going past that, you can, of course, continue the zonal shift. You can reset the expiration time. Where would you find zonal shift? In the list of services that we have. So zonal shift is part of the Route 53 Amazon Route 53 application recovery controller. The recovery controller service itself has two components to it. That is a component that helps with recovery of multi-region applications and multi-AZ applications. The part that we are discussing today is, of course, multi-AZ with zonal shift. What resources can you use zonal shift with? You can use it with an application load balancer or a network load balancer. Those are the multi-AZ capabilities that we support, components that we support today. We support these in a cross-zone disabled mode. The capability is available in all our regions in the standard partition and also in the China regions. And you can expect this to be available in the remaining regions very soon. Now, it's been over a year since we launched zonal shift. And a lot of the feedback we got from customers was around, well, what I'm responding to in many cases is a potential impact within AWS in an AZ. How do I know that? How can I detect that confidently, given that I have services running lots of different accounts? And if AWS likely knows that there is a potential impact, why can't AWS actually press the button and apply zonal shift to my resources automatically? Based on the feedback, that's what we launched today. So we have zonal auto shift now. So we would press the button automatically for you. But there are some key caveats to this. So we would do that when there is a potential impact in an AZ. And that means we're going to take capacity away from an AZ for your application when we see this impact. And given that it can have an impact on your application's health, for example, if you don't have enough capacity in your remaining AZs to tolerate the extra traffic that comes in, it can actually make the situation worse for your end users. So that is why this is an opt-in. We want you to opt in and tell us that it is OK to press the button on your behalf. You can do this with the resources that are supported today, which are NLB and ALB. Turning it on is, of course, pretty simple. You go into the zonal shift console, enable per resource, you turn on autoshift. When you do this, what happens is there is a change to the shared responsibility model. As Gavin was talking about, the piece that was still something that you owned around detection and recovery was with the compute. And when you turn on zonal autoshift, it shifts back into AWS side of the responsibility model, where if we detect an issue, we are going to press the button for you. Pressing the button, of course, means that you have to be prepared for it. Prepared in what way? You need, again, sufficient capacity. And you've heard the word capacity a lot, because that's kind of what we talk a lot about customers, what happens when we shift traffic away. There is a happy case where things are operating normally, and load is perfectly balanced, and each of your application, each AZ is running well. When a zonal shift is applied, or let's say an auto shift, you're going to remove capacity in one of the AZs, which means you're going to see that extra load again in the remaining AZs. Now, if you're unprepared for this, then this can actually create a brownout situation for your clients. And that is what we want to avoid. And hence, preparation, being prepared for this is very important. So what we are adding along with autoshift is this capability called practice run. So when you turn on autoshift, you're also getting practice run, and it is required. So you cannot use autoshift without practice run. They go together. The idea behind practice run is we will apply a zonal shift automatically for you on a weekly basis for the resources that you opt in. So for 30 minutes, once a week, we'll pick one of the resources, or each resource will have this behavior once a week. It will have a zonal shift applied. So in the siloed architecture, again, you would expect a zonal shift weekly on the front end. So you would likely sign up your enable auto shift for your front end load balancer, and that's where it's going to apply. And in the non-siloed case, of course, you would enable this for each of your load balancers, both for your front end application, front end portions of your application and the back end portions. I should also mention that when in this type of an architecture where likely there are lots and lots of applications running, lots of teams involved, practice run is not a game day type of an event. So each of these practice runs, each application of zonal shift on these resources is going to happen independently. The reason why we do that is so that we make sure that each of your teams and each of your services, you can observe them independently and verify that they are able to tolerate the loss of an AZ. One question we have already got from customers is, can we use practice run independently, even without turning on auto shift? Yes, you can. You can turn it on. You can turn on practice run. It's similar to using zonal shift, applying zonal shift yourself, calling that API. But if you add practice run, this is, again, automating that and checking how your application behaves before you also enable auto shift. When you set up a practice run, one question, of course, you've got is, well, can I set it up with certain times of the day or certain days blocked off? Because maybe you don't want a practice run to kick in on a peak day. Let's say it's a Black Friday event or a tax day or anything that is important to your business, you don't want a practice run to add entropy into your system. So yes, you can do that. You can set up both block times and block days. However, it is important also to remember that an event can happen at any time. Reducing the number of block windows and block days is also good to do over time. So what we recommend is building up the confidence to reduce those block windows down over time and eventually have as few as possible so that you're prepared for an event at any time. Another callout I have is on what happens when there is a practice run and potentially your application's health starts to suffer. So part of the contract with a practice run is actually to give us an alarm that we would look at and stop a practice run on if that alarm happened to fire. We would also look at that alarm before we start off a practice run. So let's say if you're doing a deployment already, or you know that there's something else going on in your environment, you don't want a practice run to start, this is the alarm that you would trigger, and we would actually monitor before and block off a practice run. We recognize that it's also important to observe an autoshift or observe a practice run when it's in place. So you can set up notifications with Event Bridge to do that. I also want to call out some trade-offs and sharp edges that exist. So you are making a business trade-off when you set up autoshift. So the trade-off you're making is around, excuse me, is around pre-scaling. So when you turn on autoshift, you're also signing up for pre-scaling your resources in the other AZs. So what pre-scaling lets you do is make sure that you have a fixed recovery time or a bounded recovery time. And along with that, what you get is a better client experience. So when you use autoshift, we are assuming that you're also using pre-scaling along with that. So those strategies go together. If your strategy instead is to rely on auto-scaling, let's say, as a response to an event, then autoshift is not the one to use. So, but what you get in turn is a more unbounded recovery time and likely a worse client experience. But that is the business trade-off that you would be making. What we also launched with autoshift today is a capability in the fault injection service. This is something that you can use complementary with zonal shift and autoshift. The idea is you can introduce a power loss test and actually simulate a power failure in an AZ and check how you can use zonal shift as a response to that. With that, I'm going to hand over to Gavin. I'm losing my voice for some reason. So Gavin, if you want to take the takeaways.
Sure. Yeah. So yeah, we just wanted to give you a few takeaways to finish out with. And if you like photographing slides, this is probably a good time to get your camera out. But just to kind of come away with a few things that are important to think about here. So I mentioned before, obviously, the AZ resilient design is critical. If we're going to shift away from AZs, you really have to have an application where we're likely just dealing with gray failures. We're just shifting away from an AZ. If you have, you have to have made sure the application is set up that way in advance. The way we go about this then is to identify the gray failure in one AZ and just turn it into a hard failure by just shifting away. We don't actually block traffic from going into that AZ, we just steer it away. As a general rule, when doing your AZ resilient design, you're welcome to use any data store you want, any technology you want. We tend to prefer managed regional services that handle AZ failure, especially on the database layer. There is a balance to be struck between cost. I mean, in order to be able to do this quickly, you really do need to be pre-scaled. So there is a balance to be struck between the cost of that. Most services we find are not running 100% or like 98% CPU all the time. So most people have some headroom. It just involves a little bit of a top-up to make sure that you can immediately shift and not have an issue. But there is a balance there. Some customers, that's not going to make sense, or some services, that's not going to make sense. But having that bounded recovery time to just say, look, as soon as there's an issue, we're just going to shift, or rather, AWS is going to shift for us, that will really shorten your recovery time if that's the critical issue for your business. Zonal autoshift obviously is effectively taking over the role on your behalf of centrally detecting at least widespread AZ impairments and just shifting the work away. If you happen to see an issue that's only impairing you, you still have zonal shift, you can still use it yourself. We're looking for the widespread issues. And finally, the importance of not doing this once every 18 months, 2 years. You really want to be, you can imagine setting this up in January. You do a nice load test, you really prepare everything, and 18 months later, after your service has grown substantially since then, finally this comes along, autoshift triggers, but your traffic's much larger now, and you didn't remember to scale up, and we haven't tested it since, and things may not go so well. So that's the reason we build the practice into it, is to make sure that we have a good relationship, we're regularly practicing, we know this is going to be safe, and it allows us to move fast and not worry about whether we're going to hurt customers, because everybody is practicing with us. So that's the key kind of takeaways we wanted to give you. Deepak and I are going to head out this side and answer any questions you have afterward. Thank you very much for making your way down here and listening to us today.